All right, welcome everybody. Um, Tuesday of week 8. So today's question of the day, and we're gonna ask Junior again when he comes here. If I forget, someone please remind me. Um, if you could only have one type of cuisine to eat for the rest of your life, what would it be? I thought this was a really good question when I saw this in my list. Huh. I'm gonna start off. Oh man, that's tough. That's really tough. See, I already have some questions that I would ask, like, what about like for dessert? Could I have something else? Like, does it have to be a part of that cuisine? Like, that's it's really tough. It's a good question. Oh man, I really like a lot of types of food. I feel like a quote unquote correct answer maybe would be tomorrow, but honestly, I keep thinking of butter chicken right now and like chicken tikka masala, stuff like that. So I want to say Indian food right now, but I don't know if I could eat that every day. Um, Man, this is a tough question. I could only have one type of cuisine. I'm gonna say Indian. I'm gonna make it different. I want to say Indian food. Indian food is what it's gonna be. I don't really get Indian food here in Guam. I have to make it. I make a really good butter chicken, by the way. Yeah, I'm gonna say Indian food right now. Matt, you're the first one on my screen. What you got, Matt?
Hello. Um, hmm, I don't know. I'd say Italian. I kind of want some Italian. I think I could eat like pasta and I forgot what other stuff people in Italy make, but like I'd say Italian. That's a good one. Adrian.
I think for me, it's easily Japanese. I don't think I'm willing to sacrifice sushi. I'm gonna list all the cool things. Sushi, onigiri, miso soup. What else is there? Yakitori. What else is there? Edamame. Like all of those are pretty healthy. Like I think Japanese cuisine in general is designed to be like pretty healthy. So besides some other stuff, but to me, I can't give that up, and I'm okay with that. Fully okay with it. Kiko.
I think that's a good answer.
Man, this is really hard. Uh, I mean, I could give up tomorrow food because I lived in the States for a pretty good while. Uh, I didn't really care to go look for the Chamorro restaurants either. Um, uh, but I think I would go with Adrian because like I me and my girlfriend we probably eat Japanese or Asian, something Asian, uh, probably like I want to say like 4 to 5 times a week. So yeah, I'd go with Japanese.
Dang, you guys have good answers and good reasons. Maybe I'll go Japanese too. I'm trying to live for a while. Not trying to be too unhealthy. I don't know. Good answers, guys. Cool. So we're gonna ask, remind me, we're gonna ask Junior when he gets here. And maybe we'll ask Ron again tomorrow when Ron gets here too. And I'm gonna ask Lana when she comes here. Okay, so for today, I want to do a review of everything we did yesterday with regards to authentication. I do also want to show you guys some other things with regards to like um what's it called? Other things with regards to authentication. Like how like decrypt is hashing passwords or what it means to hash or decrypt a password. Um, and kind of some other things that are actually pretty cool. But first, we'll go ahead and do a review of what we did yesterday. That's the first thing we will do. Okay, go and do that. This. Let me pull up one of our APIs. Solid. I'm gonna pull up the let's go to week 6. Week 6 we have a bunch of APIs. Solid. I'm gonna pull up the store API, for example. Okay. Oh, I already did it in here. Oh, okay. Good to know. So I'm just gonna make a new API. Why not? Whatever. I'll make a new API. Rails new auth practice 2 API or auth practice API 2. Okay, let's do this. And I'm also just gonna pull up the authentication guide real quick over here. What is this? Bonus. Okay, we go to an ls cd into it. Open it up. And now I'll pull up that guide real quick and pull up my terminal. I'm not going to push this one up to GitHub since we already have it. So I'm not going to do that git init or git status and all that right now. But just to make sure it's working, go to Rails DB create, Rails S. I go to localhost 3000. Solid, we can see it's working. Okay, cool. So the first thing we're going to do to set up our authentication is we're going to install the gems necessary. So I'm going to go to my gem file, and we already have the bcrypt gem in here. We just need to uncomment it. And then we also need to add the JWT gem. And I can add a comment if I want. We're generating the token, JSON web token. Okay, after I do that, of course, need to run bundle install. I need to install the gems. And then from there, then I can go ahead and generate the user model. So let's go ahead and generate the user model, Rails, generate model. And then it's going to be user singular because it's a model. And then it's going to be, we can do like name, string, email is a string, and then password digest, which is also a string. And we're doing password digest instead of password and password confirmation because we're using bcrypt, and basically bcrypt is going to take care of turning this into password and password confirmation. Okay, cool. So I can go ahead and click enter. I can go ahead and double check my, what's it called, the migration file, which is in db migrate solid name string, email string, password digest string. That all looks right. Let's go ahead and migrate it. db migrate. Solid. Check out my schema. I have my users table. That looks good. And then now the next step is going to be basically adding our validations and finishing setting up the authentication. So I need to go to my app, models, user.rb. And so we need to add the has secure password. And we should definitely add the validates email uniqueness, uniqueness. Excuse me. Uniqueness : true. Did I spell uniqueness right? Uniqueness. Why does it look wrong? Okay, I did spell it right. Good to know. Solid. So I set up the validation, what's it called, email. uniqueness is true, basically to make sure that each email that we create has to be unique. We cannot have the same user twice with the same email. That'll mess up our authentication. And then we have our as secure password, which comes from bcrypt. And this is what's going to take care of the password and password confirmation. Solid. And then I guess it's a good place to test it out. Let's go ahead and test it out. Let's go into Rails console. I'm just going to go user equals user.create, and I'll do an exclamation point. Why not? And I'm going to go name colon Leon, email colon Leon at test.com, and password colon 123, password confirmation colon 123. Click send. Solid. We can see it created. We can see our user. If I attempt to create that same user again, it's going to fail because that email has already been taken because of the validation that we added. Solid. So everything here is working like what we expect. The next step is, again, we're able to do this in Rails console, but we need a way for other people to create users in our application. And so the way to do that is to create the controller. So Rails G controller users, plural, because it's a controller. I'm going to click enter. Solid. That created our app controller users controller. And really all we need in here is the create action. We don't need an index or anything like that. If your app, it makes sense for you to have an index, then sure, but for our app right now, we're just going to do a users controller or an index, I mean a create action. So def create and then from there in here, I'm going to go like user equals user.create. And then we'll have like name, params name, email, params email, password, params password, and password confirmation, params password confirmation. And then we can go, actually, I'm going to do the .new instead of .create. Let's do .new. So now that way we can go if user.save and else. So if the user saves, then render JSON user, let's say, and also just give a status of created. Else render JSON user.errors, and then give a status of unprocessable entity. Solid. This looks pretty good to me. I need to go and test it out. So let me go to my config routes. Let's create the route for it. It's going to be a post / sign up, or I could do / users, completely up to you, to the users controller hashtag create method. Solid. Let's go ahead and test it out. HTTP. It's going to be / sign up. Email. So let's go. Yeah, I'm going to go and use this account. Name is test, password 123, 123 testing at test.com. Click send. Oh, my server's not on. There we go. Server. Solid. Click send. No route matches post / sign up. Post / sign up. Oh, did I spell SIGNUP? S. That's spelled right. Sign up. Post. It's a post request. What is going on here? Browse. Post / sign up. I'm actually not sure what's the problem is. Where's HTTP? Gosh, where's that? Let's restart my server. Send this again. Do I have anything? I don't have anything else. 404 not found. No route matches post / sign up. What is the command I ran when I created this? Oh my gosh, that's why. Okay. So there's a reason why I have you guys do the dash dash API dash dash database equals PostgreSQL. So because I didn't do the dash dash API, there's technically a difference between this application and the one that we've been doing. So right off the bat, if I go to the application controller, here's one huge difference. So we can see that, what's it called? This one that I just generated without the API flag, I did not do the dash dash API. We can see that the application controller is inheriting from application controller base versus application controller API. Basically, there are some differences between doing a regular full stack, like a Rails API with not being an API. I'm sorry. There's a difference between building a regular Rails application versus building a Rails API. There's some slight differences. And I forgot there's a command that I needed to add here to fix this. But yeah, why not? Let's fix this first. I forget. What is the command? Let's go and find it. Because I did it for I was teaching here. CD week. Let's go like week 2. Yeah, let's do this one. CD contact. Let's close all this. Where's my application controller? Got you. Here we go. This is what I need to add. I basically need to allow. So technically, oh hey Junior. Oh yeah, real quick, Junior. Question of the day. I remember. So question of the day is, if you could only have one type of cuisine for the rest of your life, what would it be?
My wife's too foul.
Solid answer. Okay, that's the answer.
That's it, man.
Okay, undid there. Okay, valid.
Yeah,
Okay,
I could go on forever for Stefan, man.
okay. I might. I think that's I changed my answer again. I changed my answer like twice when everyone was talking. Oh, great answer, Junior. Okay, so we were going through pretty much what we did yesterday with authentication, and actually we ran into an issue that I forgot about. Um, or something that I think it's kind of good for you guys to see actually. So I created a brand new API and I was implementing it. I already had done the users. I done up to the users controller. I set up the user model with the validations that has secure password. I added to the gem file the what's it called, bcrypt and JWT gem. And then the other thing I did was, of course, I created my user model. So if we go to my users or my schema, we can see there's users. So I'd done all that. So I went up to sign up basically, but then I was getting this weird error. I'm getting this weird error, can't verify CSRF token authenticity. And so I was like, what was this? And then I was like looking back at the command that I ran, and I ran the Rails new command, but if you notice, it's missing the two flags that we usually do. So basically, this is missing I did not do dash dash database equals PostgreSQL, and I also did not do the dash dash API. So basically, I didn't tell it to use Postgres and I didn't tell it to create a Rails API. I told it to create a Rails like full stack application. So Rails was originally, I guess a little bit of history first. Rails was originally created to build full stack applications. And what I mean by that is it was meant to originally build the UI, like what the users see, and the backend logic, right? And so when you're creating a full stack application, more than likely you're not rendering JSON, you're rendering HTML. Because ultimately HTML is what we see. Where is it? Like HTML is what we see on the screen. Like this stuff, like if I was to like inspect this page, we can see here's like the HTML code for this specific page, for example, and stuff like that. And so the point I'm trying to make is by default, full stack applications they don't render JSON, they render HTML. With that being said, when I noticed that, we got this error. So this error is basically saying that we need to add one thing to the to this application. So we need to go to the application controller. And actually, here, what I was also just showing them is that, so here, this is the one that we built yesterday that I did make an API. So we can see action controller API in our application controller. Over here, if we look at this one that I just created, we see action controller base. So this is the regular full stack application Rails. This is the Rails in API mode already. And so basically I need to add this right here. Protect from forgery with exceptions unless request.format JSON. So don't worry about everything that means, but basically what we're saying here is that, hey, this application, even though it isn't an API, it can basically respond with JSON. So that's what this is saying is, hey, it's okay to respond with JSON when we're with this application, even though it technically isn't just an API. And so now that I did that, we should have fixed that error. Okay. Still getting the same. Was there something else that I had to do? What else? I already have that. What else did I don't remember everything else that I did. I'm pretty sure it was just that. Config, I didn't do anything there. Let me take a look at my other API. 5. I'm actually happy we got this issue. Do this. Application controller. Yeah, that's the same thing. Yeah. Try this again. I'm still getting that error. Maybe it's a good time to look it up online. Let's look this up together. Okay, let's pull up ChatGPT. So I don't remember why I'm still getting error. But here, I'll show you guys exactly how I'll use it. So I built a Rails application, but I did not use the -- API flag when creating it. So maybe I'll share even exactly the command I used for that. And now, where's my controller? When I'm trying to do a users create action and render JSON, I'm getting the error in the screenshot. Here's what my controller looks like. And then I'm also going to add, I also added the request format JSON in the application controller to allow this application to render JSON, but it's still not working. See what it says. So I don't remember. I thought that was the only thing I needed to do, but I guess it looks like there's one more thing to do. App was generated as a regular Rails app with CSRF protection on by default, not an API mode. When you make requests with Postman, Insomnia, whatever, Rails is expecting that token, but the clients don't provide one. Here's what's going on and how to fix it. Application controller base default in Rails includes that. It's close, but the request may not actually be recognized as JSON if Postman setting params Rails. Option 1, disable CRSI. Change that to this. Null session prevents the invalid authenticity token and gives your controller an empty session instead of raising. Option 2, force API. So basically change it from the base to API, basically. Okay, let's try this one. Let's try this. Yeah, okay. Let's turn my API back on. Click send. Solid. Okay, cool. So that was the fix right there. So I needed to tell it, hey, basically with full stack applications, when sending a request, I guess the response there was a little bit better. It's expecting right here. Rails is expecting this token, but in full stack mode, in a regular Rails app versus an API, but the clients, and by the client, it's talking about HTTP, it's not giving a token. And so we need to tell it, hey, it's okay if if you're sending JSON, it doesn't need a token, basically. It's okay to be null. Cool. Okay. Anyway, for all other reasons, this application is exactly the same. I just had to add this one line. But yeah, so I'm happy that we got that error because something that you guys haven't seen yet. So cool. Okay, so back to the authentication. So now we're able to create a user. The next thing to do is to allow for logging in. So we have sign up, now we need login. So let's go back here and I'm actually going to pull up that guide again. So that we can follow along with it. But yeah, so this is kind of how I would use ChatGPT. I'm going to give it some context of what it is, what it like kind of maybe what my code looks like with regards to the specific thing that I'm trying to do. I'm going to tell it what I tried doing, and then I'm going to ask it to kind of give me feedback, and it was pretty helpful here. Kind of helped me figure out what the issue was and stuff like that. Yeah, so this is how I would recommend to use it for things like this. I think it's very, very helpful. And as you guys can see, it helped me fix this issue right away, which is really nice. Okay, so back to the authentication. We did steps 1 through 4, actually through 5, because we did that as well. So now the next step is to actually implement the login functionality, or basically to create a session. Solid. So let's go and go Rails G controller, and it's going to be sessions, plural. Let's pull up the sessions controller. We're going to create a create function, and then from there, we're going to go, I'm sorry, we're ready to create. We're going to go user equals user.find. Actually, it's going to be find by email params email. So we're going to find the user by their email, and we can say if user and user.authenticate, and specifically by their password. Basically, do they have a valid password? Put my end right away, put an else, and then basically if the user is a valid user, I do not feel like writing this whole line out. So I'm just going to grab this because this is something specific to Rails. And I want to do a little bit of an explanation to what this is. This is actually really cool. Lana and I did a deep dive today to what's going on in here. So actually, I think it'd be really cool. A really cool lesson to kind of go through. Cool. So render JSON. We're going to render the token, JWT. It's going to be that token that we just generated, and we can also just share the user's information. User, status created, and then else, if it fails, render JSON. We're going to give it an error, invalid email or password. And we can give a status of unauthorized. Solid. That is our sessions controller. Simple as that. Let's go ahead and go to our routes. We're going to go post/login goes to the sessions #create. Sessions #create. There we go. Turn my server back on. Go back to HTTP. Change this from sign up to login. I only need the email and password. It won't break if I send more data than what I need. So just to show you guys. Solid, click send. Here's our JWT. Solid, so that's what we need right there. There's the JWT. So we've officially implemented sign up and log in. The final thing to do is to actually add the before action and the authorized request stuff. I guess to do that real quick, I'm just gonna generate a simple products controller and model real quick, and then I'll add the authentication to it. So Rails G model products, name, string, price, and do a decimal. Yeah, that's it. Keep it simple. Let's go ahead and check my migration file. Name, string, price, decimal. Solid, that looks good. Let's migrate it. Check my schema. Solid. And then finally, now let's generate our products controller. Rails G controller products. Solid. Let's go to the products controller. Let's do a simple index and create. Index products, plural, because this is going to be all of the products. Product.all, render JSON products. And I'll do a create, def create product, because it's one singular product that we're creating. Product.create name, Rams name, oh, and price, Rams price. And then we can just render JSON product. Super simple. Finally, let's go to our routes. Let's create the routes for it. Get slash products. Oh, points to the products, hashtag index. And then post slash products points to the products create. Solid. Let's turn my server back on. Let's just make sure it works. Let's go to get slash products. Solid, empty array. If I change it to a post and I need a name and a price. Price, $10. Let's click create. Solid, we see it works. If I change this back to a get, solid. Cool. I have some product. I have a product. All right. So the final step now is, once again, right now, anybody can come here to my application and make a index or create request for my products. And I want to make it so anybody can do the index, but I only want it to be that certain people who are logged in can do the create. And so that's what I want to implement. And so to do that, we need to add some logic to our application controller. So that way we can do something like this. So basically we can do what it is we want to do. So I'm going to go to the application controller. Leave all that. And then from there, I'm going to do the authorized request, which actually I'm just going to copy this just because I don't expect any of you guys to necessarily memorize this. This is something that's going to be standardized every time that we do it. Yeah, so I'm just going to do this. Fix that indentation. There's authorized request, current user. All right, cool. Finally, now that I have that, I can go to my products controller and I can add the before action or the callback. So I'm going to go before action, authorized request. Specifically, I only want to do it for the create action. I want anybody to be able to do the index, but only people that are signed in can create a new product. Solid. Let's go ahead and test that out. Let me restart my server, pull up HTTP, and let's go ahead and try an index real quick. Anybody should do it. Solid. If I change this to a post, try to do it. Solid. Unauthorized. Exactly what we want. So let's go ahead and grab that JWT. I'm going to go back here. I'm going to go to the authorization tab. I'm going to paste that JWT in and click send. Solid. There you go. So I'm authorized to create. Cool. The last thing I'm going to show you guys is that sometimes it might make sense to kind of have this here. I'm going to comment this out. And it might make sense to do the before action in the application controller. And what I mean by that is, so here, I'm going to add the before action right here. It's going to be before action authorized request. And so now the way this works is that because the application controller is what all of our controllers inherit from, technically this authorized request is going to run before every single action. If I had another controller, like let's say a supplier's controller, this authorized request is still going to run before every single action. And so now let's say your application is something that you wanted authentication for every action. This would be a simple way to do it. Adding this into the application controller instead of in each individual controller. So now let's say you had 10 controllers. Instead of having to add this in all 10 of your controllers, you add this here one time and you don't have to worry about it. So this is again back to the idea of dry, right? Yes, Junior.
So if we do it's like it'll everything that falls under the application controller, right? It's going to run that authorized request.
Correct.
Do we have to put the before action under the definition authorized request, or will it be okay? Like, does it do it in sequence?
Here, let's go ahead and try it out. Let's go. I'm gonna put it at the bottom. So I'm gonna put it, actually, let me put it at the top first. Let me just make sure it works. Okay, so I added this here, and let's just make sure this failed. I'm gonna remove this JWT. I'm gonna click send, solid. We see it says unauthorized. And here, I'll even restart my server just to make sure that wasn't like a fluke or whatever. Cool, unauthorized, paste my JWT in, solid, it works. Now, let me go ahead and I'm gonna move this to the bottom. Fix that indentation. Click send. Solid, we see it works. As soon as I remove it, unauthorized. And so I believe the reason why this one, it doesn't matter the order is because technically, that's the way. It's a great, I'm trying to make sense of it, of why it doesn't matter.
Would it just flow? Like it goes before action, run authorized request, and then it finds it on the bottom? Like there's a reference for that?
I think it's because technically when a request is made, all of the code, it's maybe, yeah. I don't really have a good answer. I actually want to ask ChatGPT to see what it says, because I think this is a good question. Okay, so let's ask it another question. So I'm going to say, let's just copy that.
Is there an order of operations with coding?
Yes. I mean, so to Junior's question, like in most things, for example, let's go to this products controller. Super simple. If I attempted to do puts products right here, this will fail. This should fail if I'm thinking of it right. Like, let me make a GET request. I need to be authorized. I'm gonna comment out that line. I don't want to be authorized right now. Cool, perfect. So we're getting the error that we're expecting. So this is what Junior's thinking right here, is because depending on what you're doing, actually, I want to say most of the time, the order of where you're referencing something matters. You cannot reference something before it's created, technically. And so in Ruby and in a lot of languages, it goes line by line by line. So it's starting at the top of the file and then it's going down, right? And so specifically, for example, here in this scenario, we're attempting to print out this variable products. However, products doesn't exist at this point because we create it here on line 7. And so that's exactly why we're getting this error, undefined local variable or method products for instance of products controller. It's like, hey, in the products controller, you're referencing this thing called products on line 5. And it's like, hey, like that doesn't exist. That could be a variable, it could be a method, I'm not sure. What did you mean? And so that's why that's what it's saying here. However, if we go back to the application controller with Junior's example, this before action here, it didn't matter if it was before the authorized request or if it was on the bottom. in both situations, it worked perfectly fine. And so that's what we are unsure of. So I guess to answer, most of the time, yes, code does kind of have an order of operations. It works line by line in order. However, in this situation, it seems like it doesn't matter. And I don't have I have like an idea of why it might be like this, but I'm not 100% sure. And so that's why I want to ask ChatGPT. Okay, so I'm gonna ask it, like, we're testing the callback for authorize request in the application controller below. However, we noticed that it doesn't matter where we put the callback. And I'm going to put what the callback is. Oh, guys, hold up 1 second. I locked my girlfriend out again. Shucks. Oh, okay. Sorry about that, guys. Okay, back to this. We're testing the callback for the authorized request in the application controller. However, we notice that it doesn't matter where we put the callback before action authorized request, even though usually if we attempt to call something before it was created slash initialized, it'll fail with an error saying, oh, I think I know why. I think I know why. Undefined variable or method something. Why does it not matter if we put the before action before the authorize request function was created or after? So the first thing I'm going to say is that kind of already right off the back, this doesn't make sense. If we're thinking in the terms of what we're just saying, it doesn't make sense that this works. Technically, we're already calling authorize a request before it was created. So right off the back, it's like, it doesn't matter. I think the reason is because for callbacks, I think within the life cycle of like when the code is being populated, let's say, like at the time that it gets to this line, everything else in this file was already, I guess, not ran, but populated, if that makes sense. I think that's what's happening. Let's go and click send and see what it has to say. Okay. Before action on it does not immediately call the method, it just registers a callback name as a symbol to be executed later when a controller action runs. So when Rails evaluates your class, okay. Ruby sees the class in the body, does not execute. Ruby defines the method, that definition, request comes in. Okay, exactly. So technically, it already ran this file. By ran this file, it already knows that this file exists and went through what's in here. So it isn't, and then what happens is after this file is, let's say, ran, then when the server receives the request, it then goes to the routes. There's the routes. It goes to the routes. It goes to I guess this thing. And then from there, then it's going to go to the controller, user's controller, and technically the application controller in this scenario, and it sees this before action. Then it's like, okay, cool, you're trying to call authorize request. Go ahead and find that method. And so I guess the point I'm trying to make is technically the code already, in a sense, ran per se. It's not like it's just running for the first time. It's the first time this method is being called. However, that doesn't mean it's the first time this file has technically, we'll say, ran or has been like initialized in a sense. That makes sense, Junior? Great question. Okay. Yeah, so this is how I would use ChatGPT, guys. I really like this. This is like, I think this is really good. You guys get to see like literally how I would use it to ask it a question and figure something out. And Lana and I were using it for something similar earlier today. Okay, so back to our application. Oh yeah, so now we added the before action. Now it's in the application controller versus it being in the products controller, right? And so now if there's a method that we want to not be required for authentication, because technically right now, because we put it in here, it's like every single application. If we had another controller, that controller as well, all of its functions, all of its methods would require authentication. What if we didn't want something to require it? So that's where we can kind of do the inverse of this, where it's going to be skip the for action, authorize request, only index. I think this is the syntax, if I'm not mistaken. But basically, all it's saying is, hey, do not authorize specifically the index. Do not run authorize request for the index. You can run it for every other action, but don't run it for this one. And let's go ahead and test it out just to make sure it works. HTTP, here's my products. I do not have a token here. If I click send, solid, we see all of our index. If I attempt to create again, if I do a post, try to click send, I'm not authorized because I'm not authorized. We only skip the index. And so I just wanted to show you guys that this is another way to handle really the same thing. It's just basically we're adding the authorized request in the application controller versus doing it in the I guess the regular controller. Questions about this? Comments? Solid, solid. Okay. Let's see. I think that's really about it for the review. There are a couple other things I want to go through, but I want to let you guys work through this first. And then after that, then we can go through it. We can go through what I want to go through. So let's go ahead and do an exercise. Exercise. Okay. I'm gonna have you guys create a brand new API. Create a sports API. It's gonna be something like Rails new sports API dash dash API dash dash database equals PostgreSQL. Actually, I think it'd kind of be cool if you guys had to do the same thing as me here with this adding this line to show you guys that like a regular full stack API, full stack Rails application is the same thing. You should add this one line. Yeah, I'm gonna have you guys create a technically not an API. Remove that line. Note, we're not creating a regular Rails API. So we'll need to add the following line in the application controller. Solid. Okay. Cool. From there, create the DB, migrate it, or we don't need to migrate it yet. After that, create a sports model. Doesn't matter what it has. Migrate it, test, create a sports controller. And I'm going to say only the index and create, just to keep it simple. Test it with HTTP. After that, I want you to follow the authentication guide, which was this. To implement authentication. Cool. I want it so anyone can view your sports. However, only logged in users can create a sport. Solid. Questions, comments about this? All right. Cool. So you guys are good to share your screen and start working on this. Stop my share. Also, I'd like for you guys to be pushing, adding, committing, and pushing regularly. So like whenever you guys do something like a decent amount of changes, basically, should like add, commit, and push it if you want. I think it's just good practice. That's why. Hey guys, sorry, I just wanted to give you guys a 10-minute, let's take a 10-minute break. I know you guys are still working on it, and that's what I'm expecting. But it's already been like an hour and 20 minutes of class, so before I forget again, let's just take a 10-minute break. We'll come back at 7:28 and we can continue. And you guys will still have time to continue with this. All right, welcome back, everybody. Um, Honestly, you guys are just good to continue. I'm gonna give you guys probably the rest of the hour to finish this before we kind of move on to. I just want to show you guys a couple other things with authentication, basically. Yeah, so you guys are really just good to continue. Feel free, let me know if you guys have any questions. Happy to hop into a breakout room or anything like that. If you want to go into detail without anything, yeah, just let me know.
Hey, Leon, I have a question.
Yes, sir. What's going on, Kiko?
My bad. I don't know if you can see my screen or not, but I'm getting an error.
Okay.
And then in the body, I have a password, right? But do I still have to put the same stuff in the parameters?
So for one, I'd say let's remove the body. Like let's delete everything. We're not using that's a different way to send parameters, and it's gonna look different like on the server side. So yeah, so we won't
Okay.
use the body, we're gonna use the parameters.
Okay, shit. Um, See, I'm still getting this error.
So yeah, no, this is what we're expecting here. So
Oh,
email was already taken, and you also don't have a password confirmation. But password can be blank. I mean, let's take a look at your server. Let me see your server.
hold on.
Okay. So let's see. So there's the password, there's the email. Okay, okay. So I'd say let's change the email to be something else. And for the password, we'll try it again. We'll do password and password confirmation. Because let's look at your user's controller actually real quick and let's see what your user's controller. Basically, I want to see like where the sign up code is. Like what is the code for your sign up? Okay. So oh yeah, so what do you, I want you to take a look at this code and tell me what you think is going on, or like if there's anything you think that's missing.
Yeah, see, I had here. I had I had that, right?
Okay.
And then I was getting an error. Check this out. That's sign up, right? Is that
Yep.
login?
Yeah. Sign up.
Okay, so um I think I did do password. Oh shoot, password. Confirmation. And then 1, 2, 3, 4, 5.
Okay.
Let's change this, you said, right?
Yeah, make it a different one basically.
Yeah. So I was getting this same error.
So yeah, so this is perfect. This is exactly what I was thinking you were gonna get when I looked at your code. So
Okay.
it says uninitialized constant users,
Sorry.
users. And then specifically it's pointing at line 4. So let's go to look at line 4 in your code.
So this is user, right?
Correct. Okay, so now let's go back there. Let's go back and
Okay.
try it again. And let's just see if this works. Solid. There we go.
Okay.
So the issue was, if you remember, when we're referencing the model, like when we're creating or viewing, like let's say we're doing product.all, right? If we want to see all the products, it's product.all, not products. In the same sense, when you're creating a user, it's user.new or user.create versus users, right? So
Okay.
that's a thing to remember there. Yeah. Solid. Yeah, this all looks good. Hey, Adrian, are you having, I don't know if you're just messing around with a bunch of things or like basically do you need help with, like, are you getting an error that you need help with or are you just messing around with things? Because I haven't been looking for long enough. I just see that you're trying these things.
Uh, no, I'm just figuring it out. I think I got it.
Okay. All right. Just let me know. And then I'm gonna give you guys like, let's say like 8 minutes or so till around 8 o'clock. And then we're gonna potentially, no, probably take a quick break and then we'll go through some other stuff without regards to authentication. There's no rush for this, but I just added a bonus. The bonus is to make it so the before action is in the application controller. And then you're going to use a skip before action in the sports controller to skip authorization for the index specifically. So just try the opposite way to do it. And there's no rush on it. If you're not there yet, just work on whatever it is you're doing first, and then you can work on it after. Hey, Adrian, could I see your user's controller? Okay. So question. So now that I'm looking at your user's controller and the sessions controller, where is your token? Where's the JWT being generated? Or basically, I don't see anywhere that it's being generated, so that's why I'm asking, like, is that on purpose or like, is there a different way that you're trying to do it? Or yeah, what's going on? Because I think that might have something to do with the error. Because you're trying to, it seemed like you're trying to give it a code, but it's like that code's not valid. Because so then, but where is that code coming from? That's where it's like maybe you have you're generating it somewhere else, and that's where I want to like hear. Or I want to, I guess, because there's different ways you could do it. That's where I want to hear what's going on.
To be honest, I'm just lost. I'm just trying to figure it out.
No worries. So, okay. So why don't we take a look? So the users create here, and actually. Here, let's go to a breakout room so that way I'm not talking over everyone. All right, so you guys will probably have like 5-10 minutes or so. I'll be right back. I'm just not gonna breakout room real quick. All right, first I want to say, how's everyone doing with authentication? How you guys feeling? Solid? You guys okay? Does anyone have any specific questions on anything in particular? Happy to go through anything. Okay, well, don't hesitate to reach out and let me know. Happy to go through anything. And also I'd really recommend whenever you guys are dealing with authentication, I highly recommend to take a look at the guide. I think there's a couple things that I want to update to be a little bit more explicit. But other than that, I think this guide's pretty solid. It'll walk you through everything that you would need to do, basically. So before we move on, we're not going to move on to a new concept today. Actually, I want to say that. Where's my terminal? Why did I do that? Okay. I'm gonna do this. I'm gonna change it back to the regular before action. Actually, no, I want it to fail. Okay. So I added this before action authorized request in the application controller. And so that is going to run for every single controller. The users controller, sessions controller, and products controller. And obviously the application controller, but it's already going to run here. With that being said, is there any issues that anybody can think of with with something that I need to fix? There's two things that I need to fix because I did this. I don't know who's ran or not ran into this. I wasn't paying attention like that. But actually here, let's do this. Let's see the errors and we're gonna debug it together. Let me turn my server on. And let's go ahead and try signing up. I want to sign up. Leon test at test.com. Leon, whatever. Let's click send. I'm trying to sign up and I'm getting unauthorized. Why is that? Yeah. What's going on here?
It's because you don't have a token
Mm-hmm.
and
Exactly.
you can only get a token if you're signed in, but you can't sign in because you don't get a token kind of thing.
Exactly. So we're getting this unauthorized error. Basically, we did before action authorized request in the application controller, which again, it means that it's going to run before every single controller action. And so that also counts the user's controller create and the sessions controller create. So technically, I'm not able to create or I'm not able to log in or sign up. I'm not able to create a user or create a session unless I have a JWT, is basically kind of what we said there, which is a huge issue. How are you supposed to log in if, like, how can I have a JWT if I haven't even created an account or logged in, right? And so that's where there's nothing necessarily wrong with this implementation, putting the before action authorize request here. However, there's just something that we need to note. If we put the before action here in the application controller, we have to come here into our sessions controller and do a skip before action, authorize request. And then we have to go and do the same thing in the users controller. And to be even, I guess, more specific, I'd say even do the only create. Because what if we added other other actions in here? I want those to be authenticated. So I'm specifically going to do the create. Even though I only have a create action, I think it's better to be a little bit specific. And so now that I did this, now let me try signing up. Solid. Now I'm able to create a user. And let's go ahead and just test out logging in as well. So I'm going to change this to log in. I leave the email and password. Click send. Solid. Now I can log in and I can do whatever it is I need to do. And so that's the thing. That's one thing I just wanted to note with you guys. So if we end up doing in the application controller, we add this before action, then in the sessions controller and in the users controller, we need to add the skip before action because technically we cannot call authorize request before this happens because a user doesn't even have an account at that point. A user can't log in. They don't have a JWT at the point of users create and sessions create. Does that make sense with everyone? Solid. So Matt, yeah, that was where we were going through. Okay, so the last few things that I wanted to touch on is I actually kind of wanted to give like a high level of like what is hashing passwords, what is bcrypt doing, etc. So let's go ahead and we're gonna go through some slides actually. First time we're doing this in class. Okay. So before we go through this, and you guys are going to see everything, I cannot click slideshow because then you guys won't be able to see it because I'm only sharing a portion of my screen. So before we do this, I want to explain, so now that we've kind of implemented authentication, we know how an app works, how to log in, all that stuff. So for one, it's like as developers, we kind of have to assume that someone will break into our database if it's super popular. It's not a matter of when, or it's not a matter of if, it's a matter of when. And so that's kind of what I want to share because we can do stuff to protect our database, but ultimately if our stuff is like when our application's out there, like there's only things that we can do to kind of make it harder for hackers. Ultimately, like if someone puts enough time and whatever, they can probably get in. It's just a matter of making it not worth it for them to do. And we'll get to kind of why that is actually in a second. So let's go through like what does it mean to hash a password? Technically, we're not encrypting or decrypting. Technically, we're hashing a password, which basically means that we're changing this password into like different values that are equivalent to whatever it was that we originally had. So for example, this is going to be we're going to go through like a really simple hashing algorithm. So let's say we have A is 1, B is 2, C is 3, etc. up to H. So now if we had like ABC, what would we end up? Someone help me out. What would ABC be hashed into? What are we thinking? With
Is
this,
it 1 times 3?
yep, 1, 2, 3, exactly. So following this, I guess, structure, A is 1, B is 2, C is 3. So ABC is going to turn into 1, 2, 3. It's a very, very straightforward algorithm, but this is an example of like a really simple algorithm. But the issue with this is how simple it is because it's literally like A is 1, B is 2, whatever. It's really simple. It's also really simple to hack, right? So this is not the way that we would want to go. But again, this is where I kind of want you guys to kind of start thinking of like, okay, cool. So this is kind of what bcrypt is doing in a sense, or like what when you save a password, what the system is doing. Okay. So yeah, so the trick is to make it more difficult to go backwards rather than forward. So right now, going backwards is just as easy as it is to go forward. So like to go from ABC, we get 1, 2, 3. To go from 1, 2, 3, it's super easy to just go back to ABC. So right now it's kind of equivalent. Both ways are really easy. And so really the trick is to make it more difficult for us to go from 1, 2, 3 back to ABC rather than how like keeping it like the same level of difficulty, I suppose. So one way that we could do it is with some addition. So let's say we had one same exact thing, 1, 2, 3, 4, 5, whatever. So with addition, AAA becomes 3. And so this is another example that we could try. So for example, now if we had 6, now there's more variations to what it could possibly be. So let's go through this together. What are the different options that we could have for 6? Like what could 6 be? Obviously, there's a few of them, so I'll let everyone answer at least one time.
Hef.
Yep. Next. Matt, Adrian, Tico. What are some other options? What else could we have here?
3Bs.
Yeah, 3Bs. BBB. Matt,
EA.
you said EA. Yeah. Kiko, do we have any others?
Hold on, give me a sec. Um, Edition 6. 2Cs?
Yep.
Yep.
Another one we have is like DD or BD. And we also have the inverse. Whoever gave us multiple options, we have the inverse. So for example, we have DD or we have BD, etc. Right? And so we can see right off the back already, this addition, just changing it from being individual 1, 2, 3, changing it to be addition, that added a lot of complexity, right? Right off the back, it's like, okay, a password is gonna have a hacker would have a much harder time to figure out what is the code here. Yeah, so right, so we see there's different
It
options.
just makes it a million and one and then a million and one back to 0, right? Like
Exactly.
the possible combinations.
That's the goal is we're gonna make it so if the hacker wants to do it, eventually they might figure it out, but it's really not gonna be worth it for them to try to figure it out. Because there's a million different options. So they're gonna try every single option. And if they want to, they can, but that's gonna waste a lot of time and that's gonna cost a lot of money, right? Okay, so another option we have is multiplication. So with multiplication, ace could become 15, right? Or so like we have 1, 3, and 5. 3 times 5 is 15, times 1 is whatever. And so we can see already this becomes even a lot. We can make it a lot more complex. For example, like what could 6400 be? This could be like a lot of different combinations of code. And so for example, one example we could have is bedhead. But as we can see, really what we're doing here, the goal here is that we're making it much harder for us to go backwards from 6400 back to whatever actual password it is, rather than it is to go from one to the other. To go from bedhead to 6400 is easy. We're literally just going to go 2 times 5 times 1 times 4 times whatever, etc. So that's really straightforward. It's straightforward to go this way, but it's pretty complex, or at least there's a lot of different options to go the opposite way. And so that's the goal with hashing. So this is an example of a hashing algorithm that we would use in order to make our password not easy to be cracked. And so that's technically not technically, this is a very similar to what bcrypt is doing with we go back here, let's go to our user model. This has secure password. So this is calling bcrypt. Bcrypt's the one who's doing its algorithm to hash the password and make it into something that wouldn't be easy for us to solve. Wouldn't be easy for anybody to figure out what the password is. Does this make sense with everyone? Solid, solid, solid. Okay. So the next thing that I'm gonna show you guys, where's my thing? Okay. So I have this encryption algorithm thing. This is an encryption demo. So the first thing we're gonna do, I'm gonna make it bigger. So I have 4 files, and we're just gonna start with a regular password breaker, password encryptor. So I'm gonna run Ruby, and it's gonna be password encryptor. So I'm gonna do like A, B, C, D, E. So that's my password. And so we have an algorithm here. If we go to the password, or if I show you guys it, password encryptor, it's really not that complex. This is all the code to switch it into to this basically. It's not a lot going on. So now I'm going to run password breaker, Ruby password breaker. And I'm going to go, so the encrypted password is this. I'm going to click enter. And so we can see it broke it really, really quick. But it was literally just going through every single option and went A, B, 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 A, B, A, C, whatever, et cetera, et cetera, et cetera. And it broke it in less than a second. It was like 0.02 seconds, right? And so if we use, so this was following kind of that multiplication example. So this is using this example that we have there, which is decent, but it isn't that good. It isn't that hard. There's still like not very many different options relative to like a computer trying to break and try all those options, right? And so bcrypt does a lot better job. So now if we try this again, I'm going to go Ruby bcrypt encryptor. So bcrypt has their own algorithm that they use. And I'm going to use the same exact example, A, B, C, D, E. Okay, cool. So look at how long this password is. We can see this is what bcrypt did to make our password. If we look at our password digest, it's going to look very similar to this. The password digest is our password that we input, for example, 123 that I've been using, hashed. So that's what bcrypt is doing. So now I'm going to grab this and I'm going to run Ruby bcrypt breaker. I'm going to paste in that hashed password, click enter. Invalid hash. Did I not? What did I grab here? Did I change them? I don't think I changed anything. I literally just used this earlier. Yeah, I didn't do anything. Initialize invalid hash. Then install bcrypt. Install it again. Do this. Okay. Cool. Ruby bcrypt. Let's go the encryptor first. A, B, C, D, E. Solid Ruby bcrypt breaker. Let me grab this entire thing, paste it in. Solid. So now we see this is running. And this is running a lot slower because what it's doing is it has to first unencrypt, or it has to encrypt AAAA into whatever based on the algorithm that bcrypt uses, and then it has to compare what it was, like what it encrypted versus this, versus the encrypted version of this. So it has to encrypt this versus this every single time. And we can see it's doing it. This is taking a long time. And this is going to take forever, right? I think I ran it earlier and it took like 12 minutes or something. I think that's how long it took because I was messing with this. And so I'll leave it running. I'm going to leave it running in the background. And so the difference between our password breaker and our password encryptor and password breaker that we're running earlier versus bcrypts is that bcrypts it gives us a lot more complex password, right? We're not just getting a simple like number or whatever, some simple hashing algorithm. We're using bcrypt's really, really robust and complex one to give us this really, really complex algorithm or hashed password, which I think is really, really cool. And so this is what makes bcrypt. This is why we're using bcrypt. I'm sure there's other things we could have used, but this is kind of one of the reasons you would use bcrypt is because it provides a secure algorithm that would take hackers way too long to try to figure out what the password is. And so this is still running, and I'm going to let it run for a while. And so this is why it's important to use things like bcrypt, use things to hash your password rather than saving it directly in the database. And so the game of security, and this is kind of what I was alluding to earlier, the game of security is to make it too expensive for hackers to break the password. Because if a broken password, let's say, is worth $10, like it's $10, let's say it's $10, they want they want me to break this password and it costs, let's say, like $10. Like that's how much they want to pay for it. However, if it costs $20 of time and resources in order for me to solve that, then it's not worth it, right? I'm not going to get $10 for something that I spent $20 to solve. I'm losing money. So that's the game of security. It's again, it's to make it too expensive for hackers to try to break your password. And again, it's not a matter of if they'll figure it out, it's when. But again, that's why we're going to make it so hard for them to figure it out that it's not worth it. And so actually here's this document that I think is very interesting. So this is how much your data costs on the dark web. We checked. This is from Privacy Australia. Take this with a grain of salt. I don't know. This is from 2023 for one, and I don't know how much I trust it for the most part, like, but I'm also like, maybe it's changed, whatever. I don't know. There's a lot of different factors. So if we scroll down here, we can see I don't know about a social security number being $1, but whatever. Online payment services login, like $20 to $200. Credit or debit card, somewhere between like $5 and $110. Loyalty accounts, like $20. A passport, like 1,000. Diploma, like $100, whatever. And so we can see like everything here has a monetary value. It's not a matter of if they can get your stuff, it's a matter of is it worth it for them to get your stuff, kind of thing. And so this is kind of going back to this example. Like we can see this is still running. It's still trying to figure it out. Eventually it will. Once it gets to A, B, C, D, E, because right now it's in the A's still. Once it gets there, it is going to figure it out. But again, is it worth it for them to figure it out? Is it worth it for them to have a computer running, wasting their time on this? Probably not. And so that's the goal with bcrypt. That's the goal with hashing the password. Questions, comments? Gotcha. Okay. So okay, I'm still gonna let this thing run in the background. So another thing that I want to share is sites nowadays, for example, everything that we're doing, and I briefly touched on this before, we do not save your passwords. If you go to a site and you do forgot your password and it gives you the password, that means they're saving your password in the database because they do not have your password. And so that's why when you go to a site, you have to do forgot your password, verify you are who you are, and then they have you recreate a new password because technically they don't have access to your password. Same as us, we don't have access to your password. We have access to a hashed version of your password that could potentially be decrypted if we give it enough time. But even at that, we're not 100% sure that that is your password. So we don't have access to your password. Again, if you go to a site and it gives you your password back, I'd recommend probably to stop using that site because they're saving your information and they're saving your passwords because that's just not safe. Okay. Let's see. There was a couple last things I wanted to go through with you guys. Okay. Another thing that I want to share, and again, I'm still gonna keep this thing running right there. So I want to go, I'm not expecting you guys to memorize what I'm about to go through with you guys, but I do want to share it. So that way you guys at least have it understand like an understanding in your head. And again, I'm just gonna keep this thing running over here. We'll see how long this thing takes. So in our sessions controller and in the application controller, we're referencing this thing called, where's it at? Rails application credentials secret key base. Rails application credentials secret key base. And so that's what we're using when we're generating the JWT. So technically, what not technically, what Rails is doing is it's grabbing the user ID and it's also grabbing this secret key base. And it's basically in using that with it's using that to create this JWT. And so when Rails is trying to encrypt or decrypt your stuff, it's not just anybody with the correct algorithm can do it. They also need these specific credentials. So this secret key base, if I go to, so every Rails application that you create has this thing called a master.key. And this is something that's created when you create the Rails application. If you guys were to clone any of my applications right now, you guys will not have this. If you guys were to clone any application in general, you will not have this. This is something that comes only when you're the one that creates it, or if someone who created it shared it with you. And so this master.key is important. The reason is it's important is because going back to the sessions controller where we're referencing this secret key base, if I type in Rails credentials :edit, and I'm going to give it a second, it brings up this. Technically, what it's bringing up is if we go to config, where is it? Credentials.yaml. It's bringing up this. This credentials.yaml is what contains this secret key base. However, as we can see, this credentials.yaml looks like a bunch of gibberish. So what Rails does is it uses the master key that you have here in order to decrypt these credentials. All right, where'd it go? Let me pull it up again. To decrypt this, so that way it can then go ahead and here's the secret key base. So so this is where that secret key base is coming from. It's coming from the credentials.yaml right here, and it's encrypting it and decrypting it as needed. And so if you don't have this, actually locally it'll work. If I deleted the master.key, it'll work because locally Rails has a failsafe where it'll create a temporary one. However, if this was deployed online, that's where if you don't have this, your authentication and stuff is not going to work. Because then it's going to go to, for example, the sessions controller, and it's going to try to create this, use the secret key base that it doesn't have access to because it doesn't have the master key. So not just anybody can log in or whatever with your application. They need these specific credentials, which not everybody has. Which I think is actually really, really cool. And so now I'm going to close this because I don't want to make any changes. But yeah, so that's kind of that's the way Rails is working, and that's what this secret key base is. This secret key base is this secret key that Rails wants to add to your JWT to make sure it's safe and specific to this application. So that way, not just anybody can encode it or decode it. Only the person with the secret key base can do it. And you can only do that if you have the master key. Questions, comments about that? Okay. So basically, our stuff is, I don't want to say as safe as it could be, but it's pretty safe, you know. No one's just going to come in here and find your passwords, right? The other thing is this thing is still going. This thing is taking forever. We'll see if it finishes before the class ends. The final thing that I wanted to share with you guys, and I'm going to pull up another slideshow. We're not going to go through all these slides, but more or less, I want to share. Actually, whatever. We can go through some of these slides. Yeah, so we're going to go through all these slides, and there's certain slides we're going to kind of skip through because they're just not as important, I don't think. So the stateless web. So when websites first started out, they're often hosted on a single server with many users connecting to that server. So we can think of this like, imagine your computer. So when you do Rails server, imagine that was online, right? And people were all pinging your server running on your computer. So in the beginning, that's kind of fine. You don't have that many users, there's not that many traffic. Like having one server is fine. So you can have many different users using all the same server, which actually I'm doing the same thing. So like for most of the applications that I've built, it's hosted, there's one singular server that's running it. So like if I go to the logs, here's the, for example, here's the server, like the Rails server for this specific application. And so I have one server that everybody's pinging the same one, which it's loading and whatever. I'm not going to wait for it. But anyway, so that's the way most small applications work. A lot of them, not all of them, but a lot of them. And so what happens if the server goes down? Your website's down, right? You'd crash. You don't have a website. And so often what happens is there's two reasons why we're going to use this thing called a load balancer. For one, actually, let's go through this, read it. That's why this architecture is recommended and very common. Your website can be hosted by multiple servers. And so the reason why you would use multiple servers, for one, it's so that way if your server goes down, you have another one up, like your application's not down. But for two, the other reason would be, let's say you have like millions of users. Having one server just won't cut it at that point. You know, you need multiple servers. It's going to be, there's too much traffic. And so when each server, so then when you have multiple servers, you're going to use something called a load balancer. Basically, when each server uses a web request or sends a web request to your server, it's first going to hit this thing called a load balancer. And that's going to decide which web request to be sent to. So the load balancer's job is to make sure that the traffic is distributed evenly across all the servers. So if this one has a lot of requests, all right, cool, let's send it to this one. If this one also has a lot of requests, all right, cool, send it to this one. So that way it's spread out evenly between all the servers rather than one server working too hard. That's the idea of a load balancer. Everyone tracking so far? All right, cool. All right. So another critical advantage, obviously, is if one server goes down, we're fine. We still have our other two servers, right? So we'll be fine. The traffic will be, the load balancer is not going to send it to the broken server. It's going to send it to the next server. So the users won't even know. However, let's do this. So if you guys remember when we first brought up authentication yesterday, we originally talked about how there's two different types of authentication. So there's session-based authentication and token-based authentication. If we remember, session-based authentication is where the server keeps track of who's signed in. Token-based authentication is where the server doesn't know who's authenticated necessarily, or it's not, I don't want to say doesn't know, isn't keeping track of who's authenticated. Instead, we have every time a request is sent, we're sending a token, for example, JWT, to let the server know who the user is and what they have access to do. So if you remember, we have these two types of authentication. So going back to this stateless web thing, so if we're doing session-based authentication, we could have a potential issue. Let's go scroll down. Whatever. Where's the one that I want? Actually, I passed it. So basically, let's disregard the slides for now, or disregard what they say. But basically, so let's say that we're doing session-based authentication. So in this scenario where the server's keeping track of who's signed in. In that situation, let's say server A right here, we have A, B, C. I'm logged in and I'm signed into server C, let's say. All right, cool. What if server C goes down? Now the server that knows who I am and is tracking that I'm logged in is down. So effectively it kicks me out and it logs me out and I have to relog back in and do whatever it is I was doing for the next two servers. However, with the token-based authentication, one of the benefits to using token-based authentication is if one server goes down, that server didn't even know I was logged in anyway. I'm sending a token for it to tell me who's logged in. Okay, so cool. The next request I send is just going to go to server B or server A. And so that's one of the huge benefits to using token based authentication versus server based authentication. There's other pros to using session-based authentication. It's like it's all in one app. It knows whatever. There's pros and cons to both, but nowadays I think a lot more applications use token-based authentication. Yeah, there's other slides here, but I guess the final thing I'll share is that the final thing that you need to understand is that every single time that we send this request, we need to, as we know, we need to be sending that token, that JWT. And so with HTTP, the way we're doing that is we're sending it in the auth tab. We have this auth and we're sending that token, the JWT. When we get to the front end, when we get to the front end, actually, we're going to be saving it in the browser, technically. So like if we open up the browser console, go to like application, there's like we can save it in our cookies, we can save it in local storage. There's different places we could save it. And so basically that's how it's going to end up working once we get to the front end, is that we're going to be saving it in the browser. So that way every single time that a request is sent, our browser is the one sending that token. So that way the server knows, hey, this person's a valid user. They can do whatever it is. Yeah, this thing is still running. Okay. Questions, comments about anything that we've went through? Everyone feels pretty okay? So and so. If you guys feel what's it called? Unsure about authentication, for one, we're gonna continue to go through, we're gonna continue with like more practice for it. Oh shoot, I didn't mean to go to repositories. Let's go to you guys' class. This one, repo. But I really recommend to take advantage of these resources and the guides. So it's an authentication guide implementing Rails. And so really like if you follow this step by step, you should theoretically have like almost no issues. And this is it's basic. Yes, this is a basic version of authentication, but it's a pretty solid basic version, I would say. A lot of times and the last thing I guess that I'll share before I kind of wrap up is a lot of times as authentication gets more and more complex, companies tend to not handle the authentication themselves. And what I mean by that is right now, we're the ones handling the authentication. Yes, technically we're using the JWT gem and bcrypt, right? However, still we're handling it all here in our application. All the code for it, with an exception of the gems, is here locally. We're not reliant on anyone else's code or anyone else's services or whatever other than what we have here. And so we're technically doing kind of like our own custom authentication. As things get more complex and people, what's it called? As like businesses grow and they want more complex authentication, oftentimes they'll use third-party services like, so there's like Clerk. So this is an example of a huge one that I wanted to actually try messing with. They take care of almost all of the authentication for you, and it's just a matter of you integrating their service into your application. Another huge one is WorkOS. So if we go to WorkOS, actually OpenAI, so ChatGPT uses it, Cursor, Replit, Bolt. There's actually a lot of big names in here that use this. And so basically the point I'm trying to make is as things get more complex, companies aren't handling this stuff themselves because of how complex this stuff gets. They go and they have other third parties do it if they don't want to run their own custom version, which a lot of times with everything that they want out of the authentication, they don't want to do it themselves. But I think this version that we're doing following this guide, I think it's pretty solid and I've been using it for a while. Even for some of the stuff that my clients are using. And so I think it's pretty solid. And yeah, this thing is still running. This is taking a really long time. I was really expecting this thing to be done. It's been like 20 minutes, I feel like, and it's still going. Maybe it took like 30 minutes last time. I don't remember. I'm gonna let it keep running and I'll show you guys a message when it's done, but we can go ahead and start wrapping up. So this is authentication. This is, yeah, the process of verifying who a user is. So the next thing that we're going to go through tomorrow, we're going to start on it, is authorization. So authentication, here actually, let's do this. So let's do this. Yeah. So authentication kind of handles who is a user. So now we need to figure out how do we handle what can a user do? And so that's kind of where authorization comes in. So authentication answers the question, who are you? Authentication asks, what are you allowed to do? Right? And so you guys have been to many different applications where it's like a regular customer can do a few things versus an admin can obviously do a lot more things. So that's where authorization comes into play with dealing with what access do you have to do in this application, or what access do you have in this application? Like, what can you do? And so that's what we're going to start working on tomorrow. And there's a lot of different ways to do it, but we're actually going to be using this thing called Pundit. But yeah, so we'll get to that tomorrow. For now, I think it's a good time to start wrapping up. Again, I'm gonna let this thing run, and I'll tell you guys how long it took. But yeah, that's really all I have. Thank you guys. Thank you guys for being here. I'll hang out for a little bit if anybody has any questions, and yeah, you guys have a great night, and I will see you guys tomorrow.
Shoot.
Bye, everyone.
Later.
Later.